Now, something very special about momentum is that it's conserved during collisions. So we've said that we need an impulse in order to change the momentum of an object. But if we consider a system such as two cars which are moving towards each other, in that case there are external forces acting on them. There's friction, there's gravity, but during the collision those external forces are tiny compared to the internal forces felt between the cars. So we can ignore the gravity and the friction while the cars are colliding. So we say that the momentum of a system is conserved during a collision. So how we can write this as an equation is that the initial momentum is equal to the final momentum. So let's imagine the case where we've got two objects colliding. Then to write this as an equation, we've got m1 times the initial velocity of body 1 plus m2 times the initial velocity of body 2 is equal to m1 times the final velocity of body 1 plus m2 times the final velocity of body 2. Let's have a look at a couple of demonstrations now where we'll be showing this conservation of momentum during a collision event. So a collision in physics is when any two bodies approach each other, interact with each other, and then either end up stuck together, moving apart, or moving together. So when they approach each other and then interact, that's called a collision. So what we have here is an air track. In a minute, we're going to turn on a vacuum pump, which will blow air in here, and there's lots of little holes along here which expel that air, and this reduces the friction between the carts and the track. So let's turn it on now. Now let's have a demonstration of conservation of momentum. When this cart travels in this direction and hits this cart, let's look at what happens. So you can see this cart moved in that direction, and this cart also continued to move in that direction, conserving the momentum. Now let's have a look at what happens when both carts are moving. You can see in that case, they were both moving this way to start with and then both moving this way at the end.
Here's a slow action replay. As the carts are moving in opposite directions at the beginning, their momentums cancel out and the initial momentum is 0. Afterwards, they're moving in opposite directions, and so the total momentum remains at 0.
Finally, let's have a look at what happens when the carts travel towards each other, but instead of having bumpers on the end, they now have blue tack.
So you can see in this case, initially they're moving towards each other. After they stick together, they go at a much smaller velocity because almost all of the initial momentum cancelled out.
Okay, so what I'm going to do is stand on this skateboard here. I'm then going to throw this ball, and you observe what happens to me when I throw the ball. Okay. I need to throw it.
So what happens is when I throw this ball, it's about 10 kilograms, the ball moves quickly to the right and I'm moving much more slowly to the left. I'm moving much more slowly than the ball because I have a lot more mass. Overall, the momentum of the system remains at 0.
Okay, what I have here is a cart with a hanging mass. Now I'm going to hold the cart stationary and pull the mass up here. Now try and predict what's going to happen when I let go of the mass.